Now we will look into Cambridge IGCSE Chemistry Paper 4 Extended, May June 2019, Variant 4.1. Question 2. Okay, Z is a covalent substance. In an experiment, a sample of pure solid Z was continually heated for 11 minutes. The graph shows how the temperature of the sample of pure Z changed during the first 9 minutes. So this is the graph here. Now question A. What is the melting point of pure Z? Okay, before we answer the question, we have to know the name of the process. Changes from solid to liquid to gas. So the process changes from solid to liquid is melting. Liquid to gas is boiling or evaporation. Gas to liquid is condensation. And liquid to solid is fusing. So this is the particles in solid. Particles in solid are arranged in a fixed lattice pattern, so the solid particles usually vibrate on the spot. Liquid particles are close to each other, but not in a regular pattern. Whereas gas particles are further apart and move randomly and freely in all directions. So this is for solid, changes to liquid, and here after it boil it changes to gas. So here what happened when we apply heat? When heat is applied to a solid particle here, the temperature rises until it reaches its melting point. So this is the melting point. So once the melting point is reached, you can see the temperature remain constant during a phase change because the added heat energy is used to overcome the forces holding the particle together rather than increasing the kinetic energy of the particle. So once all the solid particles are melted into liquid, further energy input will then increase the temperature of the liquid. So as you increase the temperature, the molecule now gain more energy, move faster, eventually reaching a point where they have enough energy to overcome the forces of interaction between the particle and turn to a gas. Okay. So now, what is the melting point of pure Z? So this is the phase where melting takes place. So the melting point of this substance is 80 degrees Celsius. Okay, the sample of pure Z began to boil at 9 minutes and it will boil to 2 minutes. So 9 to 11. So use this information to sketch on the grid how the temperature of the sample of pure Z changed between 9 and 11 minutes. So similar to a melting, so during boiling, the added heat energy is used to break the intermolecular forces holding the liquid molecule together. So from 9 to 11 minutes here the temperature remains constant. So the sample of pure Z was continually heated between 2 and 5 minutes. So 2 and 5 minutes here. So from this to here. Explain in terms of attractive forces why there was no increase in the temperature of the sample pure Z between 2 and 5 minutes. So here we can say energy is used to break or used to overcome the attraction forces between the molecules. Okay, question D. Describe how the motion of particle of pure Z change from 0 to 2 minutes. So from 0 to 2 minutes, the particles are still in a solid state. So the particle in solid usually vibrate, and when you increase the temperature, the vibration increases. Okay, question E. The experiment was repeated using a solid sample of impure Z. So suggest the difference, if any, in the melting point and boiling point of the sample of impure Z compared to the sample of pure Z. So melting point and boiling point of impure substance will change. Melting point of impure substance will decrease, whereas boiling point of an impure substance increase. So melting point here decreases. Boiling point increases. For an example, melting point of a pure water is 0 degrees Celsius and boiling point of a pure water is 100 degrees Celsius. But if it contains impurities, melting point of impure water now becomes lesser than 0, whereas boiling point of an impure water becomes more than 100. Okay, now question F. A sample of pure Z was allowed to cool from 120 to 20 degrees Celsius. The total time taken was 8 minutes so far. 0 to 8 minutes. So from 120 to 20. So 120, this is starting point X. And so 80 here is 20 degrees Celsius. So sketch on the grid how the temperature of the sample of pure Z changed between 0 to 8 minutes. So when we look back the graph here, substance Z melt at 80 degrees Celsius. That means the freezing point of substance Z is 80 degrees Celsius as well. Between 2 to 5 minutes. So between 2 to 5 minutes. 2 to 5 minutes. The freezing point now is 80 degrees Celsius. Now we have to connect all the points. Okay, use ruler in the graph in exam to connect all the points. Okay, now we will see how this experiment